Our next example is to find the domain of the function that takes the reciprocal of g of x equals x squared plus x minus 2. So first of all, we can start with any value of x and create x squared plus x minus 2 because g is a polynomial function. But now we're going to take the reciprocal of g of x, which gives us 1 over x squared plus x minus 2. So in this case, g of x cannot equal 0 because the reciprocal function does not allow 0 in the denominator. So we have that x squared plus x minus 2 cannot equal 0. However, this factors to give us x plus 2 times x minus 1 cannot equal 0, which is equivalent to x plus 2 cannot equal 0, and x minus 1 cannot equal 0. From there, we can see x cannot equal negative 2, and x cannot equal 1. So a solution on the number line would have 2 holes in it. One at negative 2, one at positive 1. So the domain of f of x equals 1 over x squared plus 2, or plus x minus 2, is negative infinity to negative 2 union negative 2 to 1 union 1 to infinity. That's the interval notation. It's the long way of saying that it's all real numbers except for negative 2 and positive 1. Now the next problem adds one more step of complexity. It adds the square root. And so in this case, we are going to have x going to x squared plus x minus 2, which is the same as x plus 2 times x minus 1. We're then going to take the square root of that and finally the reciprocal of the square root. So we start out where we can use any real number. Since our first function, g, is a polynomial function. But then we get a restriction in the second piece that says that the square root needs to have an input that is restricted to non-negative numbers. In other words, g of x must be greater than or equal to 0 so that we can take its square root. So we're looking for values of x for which x plus 2 times x minus 1 is greater than or equal to 0. What we're going to do here is we're going to start with considering the number line that we had in the previous example, where we found that negative 2 and positive 1 were in fact places where the function equaled 0. And so negative 2 is going to be in the solution set, as is positive 1. Now, we most likely will not be including all three intervals this time, but in order to tell that, we're going to check with a test value from each of the three intervals. So negative 3 would be in the leftmost interval, 0 in the middle interval, 2 in the rightmost interval. Those are arbitrary numbers in each of those intervals. So then g of negative 3 would be negative 1 times negative 4, which is positive 4, so is greater than 0. G of 0 would be 2 times negative 1, which would give us negative 2, which is less than 0. And g of 2 would be 4 times 1, which is 4, which is greater than 0. So we want to know where the function is greater than or equal to 0. So it is going to be in the outer intervals, but not the inner. And so at this point, we are restricted to x less than or equal to negative 2 or x greater than or equal to 1. So we started with any number, but now in order to have the square root defined, we have a restriction. But now in the last step, we know that the square root of g of x cannot be 0 because of the domain of a reciprocal function not including 0. And so we actually cannot include the two zeros. And so with this last restriction, we know x cannot equal negative 2 and x cannot equal 1. So if we draw these two restrictions on the number line, they both involve negative 2 and 1. The first one includes these numbers. The second one includes those. The intersection gives us the answer for this domain. So the domain of f of x equals 1 over the square root of x squared plus x minus 2 is equal to the union of the interval negative infinity to negative 2 and the interval from 1 to infinity, not including either one. The domain of a product of two functions is the intersection of the domains of the factors. This is a new piece of information now that we're going to work with. And notice that this, what looks like a quotient function, can be written as a product So remember that the domain for x to the fourth is all reals, and the domain for 1 over x squared plus x minus 2 was x does not equal negative 2 and x does not equal 1. So the domain is going to be the intersection of all real numbers with almost all real numbers. And so the intersection is the same as the second domain itself. So the domain of f of x equals x to the fourth x squared plus x minus 2 is actually equal to the, in interval notation, negative infinity to negative 2 union negative 2 to 1 union 1 to infinity. And our last example, based on the fact that the domain of the sum of two functions is the intersection of the domains of its terms. Notice here we have the sum of two reciprocal functions, and so here we know that 2x minus 4 cannot equal 0, so x cannot equal 2. Here we know that 4x plus 6 cannot equal 0, so x cannot equal 3/2. So again, we have the situation where we have two holes in the number line, this time at 3/2 and 2. So the domain of f of x equals 1 over 2x minus 4 plus 3 times 2x plus 6 is the interval from negative infinity to 3/2 union 3/2 to 2 union 2 to infinity. So I hope these examples have helped you better understand domains.